welcome to today's Lego video. Today we're going to be doing 994 Rondo ranges. So we're given an n times n grid where each cell can have one of three values, whereas 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. Every minute we want to find a fresh orange that is 4 directionally adjacent to a rotten orange, and then we want to basically convert that to make it rotten and return the minimum number of minutes that must elapse till no cell has a fresh orange. And if this can't be, we want to return -1. Okay, so just to preface this, it's been a while since I've done graph problems, so I'm going to try my hand at this, and if I can't figure it out within a certain time period, say 20 minutes, 30 minutes, then I'll probably look at the solution. So let's take a look at this. Okay, right off the bat, I'm thinking that we need to traverse through every single element, right? So traverse through all elements, and then for every single element that we encounter that's rotten, right? Every element that's rotten, we do a BFS. So we do a BFS adding the adjacents as children. So, and what we can do with that BFS, we can do a BFS using a queue. What we can do from there is iterate through the BFS, converting all the children to, I guess, make it rotten. And then we also want to keep track of the minutes while we're doing this. So I guess we can kind of design the internal data structure to do this. Let's think about this. So we have a queue. Well, let's start with a queue. And what information do we want it to have? Well, number one, we want it to have the I and the j, the actual coordinates of the element itself. And what do we also want it to have? We want it to have the current minute, like the minute that's being converted at. So we'll do minutes here, and then along with that, I think that's all we need for now. Yeah. And then for here, we'll have the I and j for minutes for now. We can add on to it later on, but basically everything that's in the queue, we can effectively convert it in the grid, and then we can pop it out from the queue. And once it's converted, we want to add its children and then check to see if it is rotten. Well, if it's fresh, and because it's a child, well, it's a 4-directional adjacent, we can go ahead and add it and then keep checking on back and forth, adding the number of minutes. And then we'll also have keep a maximum accumulator at the very end, which keeps track of what the maximum minutes are. So if this seems like a valid solution, I'll go ahead and begin coding this up now then. So first of all, we want to traverse through all the elements. So for I in range, length of grid, and then for j in range, length of grid, what we want to do is, we'll initialize a queue here. We want to add any fresh ones as elements into the queue. So we want to do guess if grid I and j is equal to I guess a rotten one, right? A rotten one, so that's going to be a 2. We want to add that into the queue. So probably want to do queue.append I and then j, and then the current minute that it's on. And because this is the very beginning, the very start, we want this to be at minute 1, because after 1 minute, then it should convert. Yeah, because we start off with at minute 0, everything's at its initial state, and then at 1 minute it'll add everything and then do that. So it should be good. Okay, So we'll add this and basically append all the fresh oranges. So at the very, well, I meant all the rotten oranges. So at the very end, we'll have basically a whole series of different numbers. Let's actually do a visual example of this. So for example, 1, a fresh rotten orange is going to be at 0, 0, and then 1, and then, yeah, we'll start off here. And then after this is populated, right, what we want to do is we want to grab every single element. So while q, while the q is in here, yeah, while the q is in here, actually we want this to be admitted 0 because that's the initial one. So while the thing is here, what we want to do is append all of the adjacents to it, so 4 directional adjacents. So what we can do is we can do cur, and we'll have that to be q dot pop. We want to pop the latest one, so this will grab 0, 0, 1 at first, and then we want to check to see if there's any fresh elements, I guess, like to the side of it. So in this case, we'll be checking the sides of it. So we'll do if I plus 1, and then I minus 1, j plus 1, and then j minus 1. So we can do that. Okay, so if so I guess we can do, instead of cur, since we're popping multiple, it's a triple one. Yeah, we can do I, j, well, actually, yeah, we'll make this in a way here, I, j, and 0. So we'll have I, j, and then the minutes to be equal to what you popped in the queue. Next thing you want to do, check to see if I is less, if I minus 1 is greater than 0, and yeah, if I minus 1 is less than 0, then what we can do is we can do a check. We want to actually check to see whether or not j is greater than 0 as well. Although it should be if you're adding it, so we've already completed this check. Let's check to see if I minus 1 is greater than 0. Then what we can do is we can do q dot append the I minus 1, then the j, and then m plus 1, like we were talking about. We want to move it up ahead. Same thing with this. If I plus 1 is greater than 0, then we want to do q dot append I plus 1, j, m plus 1. And actually we want this to be if I plus 1 is less than the length of the grid minus 1, because we don't want it to be out of bounds. Now, yeah, because of the length, for example, is 3, then it has to be less than 3. Actually, yeah, it has to be less than 3. And if it is less than 3, so if it's 2, then it'll be in the bounds. So now we'll do another one. If j minus 1 is greater than 0, then q dot append I j minus 1 and m plus 1. And then likewise, if j plus 1 is greater than the length of grid 0, that's when you want to append the I, or the I, and then j plus 1, and then m plus 1 over here. So we're going to add all of those, and then what's going to happen now is we're going to add all the ones which are fresh. Okay, so we also need to do a check to make sure that the element is a fresh orange. It can't be anything else. It has to be just 1, because if it's 0, then it's going to be empty, and if it's 2, it's already rotten. So we want to do check to see if grid I and j is equal to a fresh one. So that's going to be 1. So, or yeah, we'll do I minus 1 equal to j, same thing. Oops. I plus 1, and this won't cause any errors because we're doing a check to see whether or not it's inbounds before. We'll do I plus 1, and then we'll do j minus 1. And then after that, we'll also do and grid j plus 1 is equal to 1 before appending it. So that way it'll only add the fresh oranges. Now, after we do that, well, what we want to do is we want to convert it, and we want to keep making sure that that element is rotten. So I guess we can do that as another step. So what we'll do is we'll do grid I and then j, and we'll have that set to be equal to I and j set to be equal to the to be equal to 2, because we want to make it rotten before adding its children. And then we'll keep adding this on at the we'll also keep an accumulator, so we want to have max minutes, and then we want to have that to be 0, and then the entire time as we're doing this, we want to do we want to append and make max minutes to be equal to the max minutes to be equals max of the current m and max minutes. Okay, so let's start off and go with what we currently have in our queue right now. So we add all the ones which are fresh. So it has to be within the constraints here. And then, okay, let's start off with this one. I minus 1 is not greater than 0, so that's skipped. I plus 1, it is here, it's inside, and I plus 1 is equal to 1, so we're going to want to add that to the queue. So let's just imagine that we pop this one, and then we add 0, 1, and then 1. And then we move on to the next one. We have j minus 1. What does j minus 1 get you? Can't really get you anything, so that doesn't work. And then we have j plus 1. J plus 1 will get you this one. So this will be this will be this is supposed to be the other way around, where we have 1 and 0. Doesn't really matter, I'm just doing this as an example, but we have 1, 0, 1, and then 1 to add that one for the j. So we'll have that as our for directional fresh fruit. So basically we're just adding these two fruits, and then we're going to recursively call on it again, checking to make sure, basically adding the directional ones and then converting it to make it rotten while keeping track of the each one. So yeah, at the very end, what should be the case is we return the max minutes, and then that should be the number of maximum minutes which we're able to do. Now, another thing we also have to keep in mind is if this is impossible. So we want to make sure that every single element, basically no cell has a fresh orange. So what we can do, while we're traversing through this, we can keep track of what elements have been hit in the grid already. So till no cell has a fresh orange. So if any fresh oranges exist afterward, then we can effectively return -1 if it's impossible. There's two ways of doing this that I can think of. We could have an iteration at the very end, which basically checks over everything again and makes sure that there isn't a fresh element left, which is it's an O of m plus n operation, where n and m are basically n times n is like the number of elements in the array. But another way to make it a little bit more efficient, actually, would be to let's just do that for now. I'm trying to think of a way that we could do it as we're going along, but there isn't really a way to know. Actually, let's not overcomplicate things. Let's let's just iterate through everything in the end. So for I in range, well, actually we'll just do the same thing that we did here. Gonna iterate through, oh, just caught a mistake over here. This needs to be length of grid 0. Same thing with this one. Length of grid 0 over here. And then we basically iterate through it. Check to see if any of them are equal to a fresh fruit. So if any of them representing a fresh orange, you have it equal to 1. And then we want to return -1. Otherwise, we can just return the maximum minutes. So that takes care of this. Yeah, this one over here. Oh, and we want to return the minimum number of minutes till no cell has a fresh orange. Oh shoot, okay. Because I just realized, as soon as there's no more fresh oranges, that's when you want to hit it. We don't want to keep traversing forward until, like, we don't want to keep traversing until like even if there is no more fresh oranges. I think right now it should work because the basically this is checking to see whether or not it's a fresh orange. So there will never be an instance where the number of minutes will exceed the there won't be an instance where the number of minutes will go beyond the number of fresh oranges there are. Let me actually just quickly run this to have a quick check here. Oh, okay. Well, yeah, we need to make this a array like so. Made some mistakes here again. I'll run this again. Oh, I see. List index I out of range. It shouldn't be out of range because we're checking that over here. So something's wrong with this while we're doing it. I -1, j, and +1. I +1, j, and +1. I j -1, and then I j +1. And we want to pop that. How can that be out of range? We want to make it rotten. I want to check if it's fresh. Let's do a quick debugging statement actually. Check to see what the element is. So we'll do I and then j. What's on so? Oh, this will be recursive because there's no base case. Oh shoot. Okay. Okay, let's think about where we. Well, if it's not equal to 1, then we stop adding it. Okay, so we add 0 and 1 successfully, right? Oh, we add these elements in the beginning. But we add 0, 0. Okay, let's actually run this again. Oh yeah, okay, just because it populated in the beginning. So it's working for these 3 test cases. Let's go ahead and run this for everything. Okay, 12. Okay. So we expect -1 where, when it's supposed to be expected 1. So we encountered a fresh orange. Okay, let's actually print out what the grid looks like while we do this. So we'll print out grid. Yeah, and then we'll print out grid and then return -1. because I just want to see what the grid looks like while we're doing this. Or we'll run this actually again, and then so the grid is 1 and 2, and then SD out. Okay, so let's start off with this one. 1 is rotten over here, so then we add it, right? So it's going to be, we're going to be adding basically 0 and then 1. Yeah, well, because we're doing it this coordinate. From here, what's going to happen is it's going to pop I, J, oh, and then 0 here. It's going to pop the maximum, this one, set the maximum minutes, and then convert it. So we want to have the grid, we make that equal to 2, and then it should go take the one behind it. For some reason the one behind it isn't working. So that would be if the column of j minus 1, we want to append it, and then we want to add it. Why is this one not working? Because this one should be equal to 1. Do a test. Hit. Well, actually, we'll add what the Q is here. Oh, no. Actually, we'll just add as a test case. So it actually never hits this. So this case isn't working. If j minus 1 is equal to 0, we grab this one. Actually, let's print out what q is before. So we'll do print and then q. We start off with 0, 1, 0, like we were thinking of. Oh, whoops. We start off with 1, 2. S to the out. The Q starts with nothing. It doesn't add it. If grid I... For ij, if ij is equal to 2, it's not catching the 2 there. Oh, okay, well, sorry, because we already popped it. So we pop it. And we print the Q, it's empty. And then, actually, let's just print I, J, and then M. Okay, so we have, yeah, like expected, we have 0, 1, 0. And then, it doesn't do this one. If J minus 1, oh, that's the edge case that we're missing. This has to be, yeah, less than or equal to before you're able to do this. Yeah. Let's try running this again. Nice. Do another submission. We might be missing a few more edge cases. Okay. Okay, we're not. Line 25. Oh, okay. Yeah. This is where the typos begin. Okay. Let's try this again. Submit this. Okay, we're expected to have 5. We're expected to output 5. We're supposed to output 2. Well, no, sorry. We're expected 2 when we're supposed to output 5. We start off with 0, 0, 0. Oh yeah, because that's a 2. And then we pop that. And then we add 0, 0, 0. We pop that and we add its children. So then this becomes 0, 0, 0, 1, 2, 1, 0, 0, 0. We can get rid of this print statement actually. 1, 1, 2, 1. And then we have 2, 1, 1. So in that case, that's 1, this one. How did that happen? So you're adding a 1. Okay, let's just add this as a test case again so we don't have to do this, but we'll run. Okay. So we start off with 0, 0, 0. We add, we append, and we pop it. Well, okay, yeah, we pop 2, 2, 0, because that's here. 2, 2, 0. Yeah. 2, 2, 0. And then we make this 1 minute, and then we add all the other ones. How did it output 5 in the end? Oh, here. We want to append this, and we pop it. We want to have a scene set. I think that's what we're missing. Because there can be some overlap. If you do scene is equal to a set, and then we can do scene dot add. Basically we want to do scene dot add here. So we want to do scene dot add I and then j, like basically an array of it. And we want all of this to only happen if j not in scene. Otherwise, we're just lapping it over and over and over again. So we want to be able to effectively make sure that's not auto repeated again. Oh, actually, we need to make this a tuple instead. Because tuples are immutable, so they can be put inside to a set. Yeah. Okay. Still returning 5. When you're expected to have 2. Okay, you know what? Let's get a notepad. It's kind of hard to look at it from here, but okay. We have 211, 111, 012. You take a look, and then we add 220. So we add this one, and basically we pop this one, and then we make this one. Oops. Basically add this 00 and then 121 to the queue. So we add 121 and then we pop it 211 and then we pop 112 and 013. This becomes the third one. But some of them could probably be done faster through the other ways. I think this is the case where we need to figure out what the maximum minutes is. So as soon as all the fresh ranges are populated, that's when we want to remove it. Okay. Start off with 000. We add 000 and then 121. And we pop 211. So 0, basically 1, 2, and then 1. So this becomes 2. And then we pop 112. So this becomes 1, 1, 1, 1. This becomes 2. Oh, this is a stack. For BFS, we need a queue. That way, we'll be doing it basically for a tree. We'll have it for every single child, so the minutes will show up correctly. So once again. How do you... I think use a... Is it a deck? So we want Q to be equal from... Let me just quickly look up the syntax for this. Yeah, okay. We just initialize a deck here. Forgot. Because we can't be having a stack because that would just be a DFS. Oh, okay, there we go. We want this. Nice. Accepted. Yeah. So the mistake that I made was that I said I was going to do a BFS because you need to add it basically for all of the children. You need to be adding it, adding it and accumulating the minutes as you go along. The reason why you need to do a BFS instead of a DFS is because a DFS sort of traverses the children, adding the children and then checking that one, adding the children and then checking that one and going on downwards. But that's not what we want to do. What we want to do is we want to determine the minimum number of minutes. And we have to do that by just checking to make sure, we need to add all the children and then check all of that children before we do it. So we have to do it level by level because we want to choose the minimum level in which, level as in minute in which you want to be adding the elements at. Yeah. Actually, I'm kind of curious. Do we need a scene set for this one? Oh, okay, yeah, we do need a scene set. Yeah. Yeah, we need a scene set because it could, there could be potentially some edge cases in which you would be adding it. Or, oops. There we go. There would be some cases where it would be adding something that's already been seen before, and we don't want to be adding to that if we've already traversed through it. Yeah. So, let's analyze the time and space complexity of this. The time, this is going to be O of n plus n at first because we're iterating through everything, and then we're iterating through also O of n plus n at the very end. For this one, the time complexity of a BFS would also be O of m plus n because you're just adding everything into the basically traversing through every single elements and adding it on, and there won't be any duplicates because we have a scene set, so it'll be O of m plus n time complexity overall. In terms of the space complexity, it's going to be O of n plus m space complexity, just because we're adding all of the elements. Could be potentially, could be potentially adding all of the scene elements into the scene set, and then also the deck instead. So yeah, thank you for watching. I'm actually kind of happy about this because I haven't done graph problems in a while, and I don't know, it's just a good indicator of my LeetCode progress. So I'm happy how things are going. Well, thank you for watching.